Good day, I'm Midshipman Steven Ricky A. Santiago from AS382, and today we will discuss about the structural architecture of SCADA and DCS system on board. So let's get through it. So this is the architecture of a DCS based on what I search and from what I get from the video. So let's get True. So the architecture of DCS, so distribution control system or DCS is consists of three major qualities. First, the various control functions can be distributed into small sets of subsystems that are semi-autonomous. So these are interconnected by a high-speed communication bus, and their functions include data presentation. Right. Then data acquisition, process control, process supervision, reporting information, storing and retrieval of information. Then the second characteristics of automation is the automation of manufacturing process by integrating advanced control strategies. So the third characteristics is arranging the things as a system. So the organizing of the entire control structure as a single automation system can be done with DCS as it unites subsystems through a proper command structure and information flow. So DCS is included with basic elements such as engineering workstation, operating station or HMI, process control unit, smart devices, and communication systems. So DCS can be used in various control applications with number of IOs with dedicated controllers. So these systems are used in manufacturing processes where designing of multiple products in multiple procedures such as batch process control. So then guys, let's go to SCADA system. So SCADA systems is a collection of both software and hardware components, so that allows supervision and control of plants both locally and remotely. Then the SCADA also examines, collects, and processes data in real time. So human machine interface or HMI software facilitates interaction with field devices such as pumps, valves, motors, sensors, and etc. So the next is also within the SCADA software is the ability to log data of historical purposes. So the structural design of a standard SCADA system starts with our remote terminal units, RTUs, and or programmable logic controllers or PLCs. As you can see there. As you know, RTUs and PLCs are microprocessors that communicate and interact with field devices such as valves, pumps, and HMIs. So, communication data is routed from the processors to the SCADA computers, where the software interprets and displays the data, allowing for operators to analyze and react to system events. Before SCADA, plant personnel had to monitor and control industrial processes via selector switches, push buttons, and dials for analog signals. Then, this meant that the plant had to maintain personnel on site during production in order to control their process. But as manufacturing grew and sites became more remote in nature, so relays and timers were used to assist in supervision and control of the process. With these devices employed, fewer plant personnel were required to be on site in order to oversee and control operations. So that's how SCADA works. Again, this is Midshipman Steven Ricky Santiago from ES382. Goodbye.